Let's do an example of calculating fluid flow. Here we've got a parallelogram with corners at 4 points. 1, 0, 0, 0, 2, 0, 1, 2, 3, and 1, 4, 6, like so. To parameterize this surface, we would find two direction vectors. The direction vector -1, 2, 0 is this one on the horizontal axis, in the horizontal plane, and this vector 0, 2, 3 is this one up here. They both start at the point 1, 0, 0 and go to adjacent corners. And so we put those together into our parameterization, which gives us our start point plus u times the first direction vector plus v times the second direction vector, or you can use s and t if you prefer, whatever variable names float your boat. And this is our parameterized surface. Because it's a parallelogram, we go from 0 to 1 in both the coordinates u and v. In this case, our normal vector tu crossed with tv is the cross product of the derivative with respect to u, del phi del u, and the derivative with respect to v, like so. And if we calculate that cross product, we get the vector 6, 3, minus 2. In this case, it's constant. The normal vector doesn't change on this as we move around the surface because the surface is flat. So now that we have this, we also have our vector field, f of x, y, z is equal to y comma z comma 0. We can get on with the process of calculating the total flow through the surface. So we take f of phi of u comma v. So we plug in this formula for phi of uv into this formula for our vector field, and it gives us this formula, 2u plus 2v comma 3v comma 0. That's f of phi. We take the dot product of that with our normal, so 2u plus 2v comma 3v comma 0 dot with 6, 3 minus 2. That gives us the thing we're going to be integrating, and then we calculate it with a double integral. Our region of integration is 0 to 1 and 0 to 1, and our integrand is what we figured out above, and if we work this out, it turns out to be equal to 33 over 2 in this particular case. Now we have to interpret it. We have to say we got a positive flux, and so we have to know which direction is that flowing through this surface. If we look at this picture, it's giving us a picture of a kind of parallelogram that's leaning out of the screen towards us. And the normal vector, 6, 3, minus 2, kind of points downward, outward of this from the screen towards us in our direction. And so that's telling us that the flux, the net flux, is coming out that way. It's coming from the top of our hand down through the bottom of our hand if we hold it like this. And that's how the flux should be interpreted here. So that's how this is being calculated.